All right, so we are continuing our level 1 review. This is, we're going to do numbers 3 through 10. Pretty simple. 3, 4, and 5. All we're doing is factoring out a GCF, which stands for greatest common factor. And what's going to happen is once we factor out the GCF, once we find the GCF, we're going to divide it out of both terms, and then usually have a binomial, which is a 2-term, as a result. It's basically once we find the greatest common factor, we are dividing out and we are taking that out of each one. So like 4x and 16, what's the greatest common factor between both? I love to think of this factoring out a GCF as reverse distributive property. Reverse distributive property. So here we go. 4x plus 16, there is not an x in both of them, so we cannot factor out an x. What we can factor out, what's the highest factor that goes into both, is 4. I'm going to factor out the 4, and then what is my result? I have a binomial as a result. So basically 4x divided by 4, which is x. 16 divided by 4 is 4. I basically did the reverse distributive property. There we go. We just factored out the GCF. Same thing here. We can only factor out a number, a constant, because there's not an x in both. Well, since 14 doesn't go into 21, what's the highest factor of both? Well, that's 7. Factor that out. And I basically divide. 14x divided by 7 is 2x. 21 divided by 7 is 3. The sign stays the same. And number 5, I can't factor out an x, but I can factor out, let's see, a 5. 15 doesn't go into 50. 10 doesn't go into 15, but 5 is the highest. It goes into both. 15x divided by 5 is 3x. 50 divided by 5 is 10. Reverse distributive property. All right, difference of squares. Here we go. Difference of squares. All we need to do is know the square roots of some numbers. All right, it's always set up as 2 binomials, right? We take the square root of each term, okay, and then we put the square root of the x squared first, well, because that's listed first, x and x. My signs are always 1 plus and 1 minus. Always 1 plus and 1 minus. What's the square root of 81? 9. I just factored out using difference of squares. X plus 9, x minus 9. That is factored. For number 7, we're doing the same thing. 2 binomials. We're going to have 1 plus and 1 minus. That never changes. Don't be confused with the x squared being second. That's okay, right? We still place it in order. So square root of 36 is 6. So now we just put the 6's first. Like notice the x's were first over here because the x squared was first. The 36 is first, so I'm going to put the 6's first. What's the square root of x squared? Well, that's 2 x's. The square root and the square cancel each other out. That's just 1 plus x and 1 minus x. 6 plus x, 6 minus x. Factored using difference of squares. And then finally, set up the same every time with difference of squares. 2 binomials, 1 plus, 1 minus. Now this one is kind of a double, right? So we got the square root of 4x squared. We have to do the square root of both. Square root of 4 is 2. Square root of x squared is x. So we're going to have a 2x on both of them. Square root of 49 is 7. Sorry if it's a little messy. Right, but we have 2x plus 7, 2x minus 7, because we took the square root of both. It's okay to take a square root of something like this, 4x squared. That was 3, 4, 5, 6, 7, 8. I'm going to switch to 9 and 10 real quick. All right, here we go. I love this. It's kind of like being a detective, right? Find 2 numbers that multiply to 12 and add to 7. So what we do here is we take the factors of 12. What are the factors of 12? And we take those 2 same numbers that also add to 7. Factors of 12 are 1 and 12, 3 and 4, and 6 and 2. Which one are the only ones that add up to 7? 3 and 4. 3 and 4. Okay, and the next one, All right, and number 10, here we go. Find two numbers that multiply to 72 and add to -1. Well, I'll tell you what, I had to do some math on this one, and I don't think it's going to work. And so let's double check. I did have to double check. And so factors of 72, there's a lot of them. I was thinking 8 and 9, right? The two numbers that multiply to 72 but add to -1. Well, that really won't make sense, even though there's a difference of 1 in between them. So really there are no two numbers that can multiply to positive 72 and to -1. Now, if this was negative 72, then it would work, right? Because 8 and 9, one of them would have to be positive, one of them would have to be negative. Well, if we have -9 and positive 8, well, -9 times 8 is -72. And -9 plus 8 is -1. But that would only work if 72 is negative. If 72 is positive, there are no two numbers that multiply to positive 72 and add to -1. So really on this one, just kind of focus, for example, on like number 9, right? Positive 12, add to positive 7, 3 and 4. There we go.